We're just going through some exercises from the Purescript example, and we're just trying to work out the smallest and largest files from a file system. So we're just trying to find the smallest, and this is what I've got up to so far. And we're just using, they're called blocks, aren't they? No, I've forgotten. Holds. That's what they're called. Yeah, so we're just using them to sort of help us. So I don't want to put only files in that now, do I?
So you could use only files, but the problem is, your full function is going to have to check the sizes, right? So if you look at the type of size, then it returns a maybe, and if you look at the implementation, it's doing the file check for you anyway. So you sort of not gaining anything by doing it. If you only knew the type of size and you didn't know how it worked, then maybe you'd add it anyway. But since we can just see what it's doing, we're just doing the same work twice there, right? So I would just leave it out for now.
Oh, okay.
Yeah.
So it goes straight.
So you have to add something in there that's going to have that type, right? Path to path to path. So I would just add that in a where clause.
Okay. And call this something else and have it in a where?
Yeah, like call like smallest, or pick smallest or something like that.
I see. Yes. Tab. Where? And then that would be, so I need a path to path to path, so I need to, lazy. Okay. See, that's right. Call that A again. Cool. Yeah, so let's just stop there. So colon I's, it refreshes the PSCI, and then when you do a hold here, that gives you a whole A as an inferred type of path. Okay, so that's fine. So that's just returning that. I think that's a bit where I struggle, is just understanding properly how to use this. So every time I've watched Christoph doing it, it's been like, cool, that makes loads of sense. And as soon as it comes up to me using it, I'm so I don't know what I'm doing.
Yeah, Christoph and I have spent the last, I don't know how many months, basically just, working with typed holes nonstop. So there's some tricks up our sleeve now. Yeah,
I think that's a bit that I'm finding difficult to grasp. In my head, I know totally what I want to do, but then to get that laid out and then using holes to help me with it, I think it's a bit that I struggle with when you split directions and you start doing one thing in one and the other. That's the bit I don't know how to create that and spot where I should sort of be doing different things.
We were discussing this the other day, actually. It's sort of interesting. There's the raw tool, right? That's useful, and you can sort of see why it's useful. But then you start developing these patterns of and techniques of using them, and you end up with this sort of library of techniques. And I think it'd be really good to start documenting some of those.
Yeah.
I'm not sure exactly how that would work, but I think it'd be neat to write something up. Anyway, so yeah, in this case, I would start by adding, bindings for the two arguments, right? Like path 1 and path 2 or something. And then you know that you're going to want to use the size arguments somehow. So I would add those in like a let or where binding. So you could say where size 1 is size of path 1, size 2 is size of path 2.
So another where. Oh.
Yeah, exactly. And then, you know, the type tool will give you the types of those things. It might make it easier to sort of piece things together.
Okay. So size. Okay.
And this would be like one of those patterns, right? You know, it's if this were like the refactoring book or something, you know, it would probably like, you know, introduce introduce argument or something like refine the type of the type solve or something. But you know, the idea is that we know we have a function that and an argument we can apply it to, so we do that, and then we get more information that we can use to solve our goal essentially. I think you just want to use an equals there, by the way, like you had before.
I'll say it was equals. Okay.
Yeah.
Okay. So it's in the do that I'm going like that. Okay. And then I assume I do size 2 and path 2. But is that correct? Just still to leave that as a. So A is a path 1 is path 2 is path. Maybe int. Okay, so that is returning us a maybe int from what path does, which is here.
Mm-hmm.
So then that tells me that that's returning us something useful, which are these two guys. But then I'll need to compare those guys, won't I?
Right, exactly.
Of which one's the highest and which one's. So how is it finding path 1 and path 2 from that? Because I'm only giving it root.
Because you're folding over the list of all files, right? So it'll start with root, and then it's going to basically call pick smallest for every new file it sees.
Okay. Yeah. Yeah.
And every time you do that, the first argument is going to be the current smallest thing, and the second argument is going to be the next file it found.
Yeah. Sorry.
Beat the current best, smallest size.
Yeah. So it's yes, I go like current and then accumulative. So it accumulates. So that one.
I want to rename them actually. Sorry,
Yeah, if I do that and then.
Poor names.
Yeah.
So I think they're the other way around, right? You're going to have I don't know how you name it. Like the best one, if you want to call it that. Yeah, exactly. Like your accumulator, and then you have the next file, the current file.
Yeah. And then. Okay, yeah, I see what I'm doing now. So I'm going to have to just compare those two then and return the one that's the biggest.
Right, but you've got to be a little bit careful, because if size current is nothing, then that means you have a directory, right? But nothing smaller than just A for any A. So that's going to be like a false positive, right? So we want to avoid that case. So I would actually use a case here. So like on a new line, if you get rid of the type tool, you could say something like case size ac size cur of. In place of the type tool.
In place of which piece? Sorry, types hold.
Question mark A. You have your question mark A for the whole. Yep. All right. So get rid of that, and then maybe on a new line, just say case. And then you can actually use multiple things in a case, right? So we'll just case on two things at once here. You can say size ac, comma, size cur.
Right.
then you need an off keyword, yeah. And then you need to give you patterns, right? So the first pattern is going to be where they're both, well, let's think about this, right? So if they're both adjust, then we can just do a comparison. And basically, I think in any other case, we just want to keep the accumulator as it is, right?
Yeah.
So you can say just, and then just a name, comma, just another name, and then an arrow, and then do a comparison.
So I'm just doing that sort of just?
Mm-hmm.
Yeah.
Well, so you got two binders, so you're going to need two. Sorry, you got two arguments, so you're going to have two binders. So,
yeah. So what is the just is just catching errors, isn't it? As in, like, say, if it's an empty. So
yeah, if it's nothing, then it's going to miss this case essentially. If either one of those is nothing, it's going to miss this case.
Okay, so that's what the just does, and then I want to.
So I would just leave a hole there for now.
Ah, okay.
Yeah, and then you're going to have one more case to catch everything else. Yeah, you still want the arrow. But yeah, just leave it like a hole like that. That's fine.
So it's going. Okay.
And then on the next line, just you can just use underscores to just basically match everything else. So like underscore, comma, underscore.
Oh, okay. What? So you can just do just underscore.
Is this in chapter 5 or am I? You're on chapter 4, right? I'm kind of getting ahead of things.
Yeah.
Here, but this is pattern matching syntax, right? So you'll actually this will come up in the next chapter. But
oh, okay. Well, I've seen that you can just I know that obviously in Haskell that. So how would it be used in this situation? You just copy. Or do you need to give it a just?
That's right. So exactly like that. If you have that case there, that's going to catch everything else now. So if it's a nothing on either side, you'll end up in this case. Arrow here, and then we'll handle this case as well. But I think in this case, we probably just want to keep the current accumulator.
So just return the cur.
Ack, I think.
Ah.
Because that means because we don't want to keep cur if it's a directory.
Okay. Yeah. Sorry, I've just got to get around. I think I'm still getting my head around recursion. That's probably why.
Yeah, it's a little bit tricky when you have a fold and both sides have the same type as well, right? Because difficult to sort of tell them apart. By the way, this is just like a stylistic thing, but the case usually we keep like the case all in one line, but
on the same line.
Yeah, exactly. If you ever have like a PSC format or something, we'd probably do that automatically, but not everything, just the between case and of. So it'd be like case, size, act, size, cur, of would all be on one line essentially. I'd say it's just style, so it's not really a big deal.
Cool. Yeah.
All right. So then this should build. I think you have to indent those though. You'll get an error. So that's fine as it is now. Then if you try and build that, it should give you like the new error for the whole.
So that one. Well, we should. Is this where we're going to do the comparing? Then I assume.
Yeah. So we can just use a guard like we had last time.
Do what last time? Sorry.
You remember the pipe character we had last time we did pattern matching? You can match on a boolean instead. So you put it before the arrow though. So you might want to put it on a new line actually. Yeah, and indent it a little bit. Actually, I think that might be okay. I forget if you need an indentation there, but yeah, okay. So now you can just stick a boolean condition in. So like, compare the two things.
like so.
Mm-hmm.
Yeah. Okay. So if that's bigger than that, I want to return that.
Well, you want the smaller one, right?
I'm doing smallest, yes. So I'm going to probably go the other way just to not make it. Is that right? No, hold on. I've confused it. I want the smallest.
And then for the other case, you can just say, actually, that's okay, isn't it? Because the catch-all case is going to catch it anyway. Oh, hold on, though. You got the wrong one, right? If, no, that's fine. Sorry. No, it's correct. But you need to return cur, not size cur, because you need to pass.
That's what I thought, yeah. Because size cur, yeah. So it'd be from there. And then that would return. Okay. And
So I think that's it. If you try and compile that, it should do the job.
See, that's the bit that what I'm not used to is because I'm so I'm so used to having, like you see where there's a where, because of JavaScript, I'm so used to having other functions almost being above.
Well, you can do that, right? You could use a let binding instead if you preferred it that way.
Oh no! I mean, it's just it's just mentally trying to get used to it. That's all.
I mean, I think there's sort of like good cases for both, but I tend to use them in slightly different situations.
Yeah.
Yeah. Depends how you want the code to read, I suppose.
Yeah. So was it missing? Name, size.
So here it's just saying that you're using the same name for two things. So you might want to just give them slightly different names inside the case.
You could just inline the definitions for size act and size cur, and that would make that go away.
These two?
Yeah, if you move the size, the application of the size function into the case, like up into the case head.
I'm lost.
So,
but
yeah,
so take the definitions you have inside the where and just basically copy the things on the right of the equals into the case. You know, so you don't have the name size ack anymore in the case.
These guys.
Yeah. So on line 26, you could just replace size ack with size space ack.
Ah, right. Yeah.
Yeah, exactly.
Yeah.
And now you don't have the same name used twice, you see.
Ah, okay. So I thought that. Oh no, they're referring to those guys, weren't they? They were, sorry. And then up the top, they were just different names of cases. Is that right? Oh, just getting a bit confused. Trying to work out what it was before.
Anyway, so you can just delete the where clause now, right? And then I think this should build and do what we need it to do. Well, honestly, I can't quite remember what I had. I can't remember what comes in the book before this exercise exactly, but obviously, since you haven't done pattern matching at this point in the book, this isn't the solution I had in mind. So maybe there's a different way where you don't have to use pattern matching.
Ah, because the next chapter is pattern matching.
Yeah, exactly. But I know other people have gone through the book and not had pattern matching. So there must be something.
Well,
deals with this somewhere.
yeah, because I've looked at other. Yeah, someone did something like this.
Oh, they're using an if. Okay, well, except, well, they're doing a comparison on.
They're just returning large.
Well, they're doing the largest file, so that's okay because nothing is always smaller than just, so that's fine. All right. Well,
But
maybe
cool.
I'll think about that next time I edit the book. Then, in that case.
Yeah. I mean, that's fine. It's still cool. So I'm basically. So just to recap, so when I'm doing a case, it's like is it similar to a JavaScript case then? So like
It's
a catch.
sort of like a switch, I guess, but it's more powerful than a switch, right? Because a switch can only deal with enumerations and things like strings and integers, whereas here we can deal with things like maybe, where we have data attached to our it's not just that we're saying yes, this matches, or no, it doesn't match. We're actually binding values to new names like size arc here, right? If we succeed. So it's like match in Scala, if you know Scala at all. Or I suppose actually JavaScript in ES6 has has pattern matching, right? So I'm not sure if you can do pattern matching in switch statements, though. Maybe you can.
Not tried it. But I assume so. Cool, but yeah, it is really, so I'm just giving it a case, and then that's like, so
so this basically says, we're going to switch based on the values of size arc and size cur.
Yeah.
If they're both present and arc is bigger than cur, then pick cur. And in every other case, pick arc.
Pick arc, yeah. And so how come I'm using the justs here? Are they like the... Yeah.
So that's because size returns a maybe, right? So we have to pattern match to make sure we have a value, because there might be nothing. We should probably try this though and make sure it works, because
sorry.
I probably haven't had enough coffee today, and I could have made it doing this. So helping with this.
I need to import root anyway. Data path.
I think this looks correct at least.
Oh.
Well, that's not good. Okay.
Let's return this root. That's all right.
Oh, well, hold on. There is one issue here, right? So we start out with root, and the size of root is nothing because it's a directory. So then, because we only have a match adjust on the left, in your case, we never get out of the case. We always basically just go back to arc. Okay, so we need one more case here to deal with the case where there's a nothing on the left. So it should hopefully only ever be the first case. But the order here is important, right? So you're going to have to put this before the last case, because the last case is always just going to match everything.
Okay. So in this instance, can that be on one line? This guy?
Yeah.
Or is that not making sense?
Fine.
Because essentially that whole line is one case, isn't it?
Yeah, exactly.
Okay, yeah, that's the bit that was throwing me, because for some reason I thought that doing that was making it into a different line.
But you can have multiple guards for the same patterns, right? So you could say, I'm going to bring size arc and size cur into scope by matching the justs, but then I'm going to have multiple cases that use those names. Right? So we only have one here, but you can have many in general.
So you can
That's
have
why I think we'd like to put them on a new line, but because if I have a new line, I'll sort of line them all up. But the way you had it in the case of one case, I think is totally fine.
Well, I'll do that just to pick up a good habit. If I do have multiples.
So I think we can fix this by just handling the nothing case, right? Is it clear why that's what's going wrong?
So root. So it's always going to return. So if the first one is nothing, then it will return. Otherwise, yes, it won't actually accumulate over anything, because it'll always be root, which is the very first one. Is that right?
Right. Yeah. So I mean, the nice thing is, because everything's pure, right? We can just sort of mentally step through this and sort of see exactly how evaluation works, right? But the point is, if you start out with, if the accumulator is ever nothing, then it's always going to stay nothing, right?
Yeah.
Because the nothing case always matches the catch-all case, and then we go back to the accumulator, and then size is going to be the same thing again, right?
Yeah.
So we need to get into a state. If we're ever in the nothing state, we need to get out of the nothing state. Right. So that's the issue.
Right. Okay.
I think we can do that by just matching, adding another case to match nothing on the left-hand side.
Ah. So it'd actually be, so I'd be bringing in nothing like that.
Yeah, exactly. And then you have to have a comma, but I don't think we care what's on the right-hand side, so that can be an underscore.
Oh yeah, that's what, yeah, that was it.
And in that case, we want to just pick. Yeah, exactly.
Ah, okay, I see.
Oh, you just need to indent that, I think.
Oh.
Indent the 28.
Oh. Hello. There we go. Yeah. Oh yeah, because I'm still. So normally. And then import data path. I'll import what?
Cool. So that looks plausible. Can we check?
Yeah.
300? Yeah, okay. Looks good. All right.
Oh, yeah. Sweet. Okay. That's good.
All right. So, I mean, in general, we'd have sort of higher order functions for, well, not higher order functions, but we'd have a library of functions for sort of doing these pieces, right? Like comparing sizes of paths and these kinds of things. And when you get to like chapter 5 and 6, you start to see some of these more general tools, right? So here you have to be really explicit and break everything down.
Okay.
Step by step, so it's a little bit verbose, but.
So would you mean like what, split this whole function out into small?
Yeah. So the in particular, matching the two maybes like that. There's a way to do that. When you get onto like type classes, there's ways to sort of simplify this a little bit. You could use like an applicative there maybe to sort of bundle some of this up, trim it down a little bit. But so this is a little more explicit. But on the plus side, the generated JavaScript is nice and simple, right?
Yeah.
So there's some trade-offs. This has its benefits.
Yeah, that's cool though.
And if you look at the generated JavaScript for this, it should be really, really straightforward. If you're looking like the output directory, file operations, I guess. Oh yeah, there's plenty of stuff in here. File operations should have it in index.js, be near the end somewhere. There it is. Yeah.
What am I looking at? Sorry. Oh yes, here it is.
Some of the thereabouts. Yeah. Right. So file smallest is there, right? So that's your.
Pick smallest. Oh, okay.
Yeah. So you see how the guards just get basically broken down into if statements.
Yeah.
And your pick smallest thing is just a var that's like in scope essentially, like what do you call it? Self-invoking function or something.
Yeah. An iffy.
Yeah.
Yeah, because that's right there. So it's just gonna. Right. Okay. That makes a lot more sense. Yes, it's a lot neater. Compare the two. Cool. Okay, so that makes sense. Okay, so I see what's going on. So then.
Yeah, I haven't worked through the Haskell book yet, but I ought to get a copy.
You seem to be doing all right about it.
Well, I mean, it's. I've heard a lot of good things about it from like a teaching point of view as well. So.
Okay. Yeah. I think I said it last time. I think it's because they're going with the fact that you don't even have to be a programmer to kind of read it. I think that's where it.
Yeah, I heard that.
I think that's where it kind of shines. Yeah, that's cool.
So I have a library actually that sort of simplifies some of this stuff. I could show you if you're interested.
Yeah, do that definitely. Yeah.
So yeah, so actually this is a port of actually I just need to get set up for a second, so I'll be a minute before I can. But it's a port of a library by Gabriel Gonzalez called it's called Fold-L in Haskell. I ported it to Purescript. It's called Folds, so I could show that if you're interested. It's a little bit of a different take on this.
No, that'd be cool, definitely.
All right, hold on one second. I'll get it set up and we can work through that.
Yeah.
Oh, I apparently can't share my screen until
I stop. Yeah.
well, yeah. Okay, there we go. All right. You see my screen?
Yep.
So I want to make a project called Fold Demo. CD Fold Demo. All right, I'll show the new package stuff as well. So I've been testing it for a bunch of stuff. So I can create a new project like this, and then I need my folds library. So I can just say psc-package install folds, and it goes and clones a bunch of stuff. And while it's doing that, I'll just import this. And I get to temp from here. Can I do that? Over here? No. Whatever. Atom temp. Do this. There we go. All right. I'll have to just skip between those, but that's fine. All right, so let's make a source directory and a main file for testing. We say psc-package build, and it will fail apparently. Oh, because I haven't created a module. All right, let's do that. All right, so say module main where import something that's called data.fold or something. Build that. Okay, so it's not called data.fold, it's called ls.psc-package.
Control.fold, I think.
Oh, it is? Oh, well, I can just show what these are. Anyway, this is visible, by the way. Hopefully you can read this.
Yeah, that's fine.
The packages are in directories that look like this. So you have the package set name and then the package and the version. And then it's just a shallow clone of the branch, right? So you can just sort of browse it like a regular directory. Yeah, so I can import this and then you can do psc package build again. Okay, cool. Let me see if I can put these together, actually. That would be better. Yeah, there we go. Go there. All right, cool. So then let's fire up psc-id as well. I think this should work. Yeah, okay, cool. So let's say I have some files and it's an array of integers or something, okay, of various sizes, or make it a little bit more interesting. Let's say we have a path and it's a string and it has a size, it's an integer. Create some of these. So I forget what the examples were, but I know there was Etsy hosts, like 300 or something. Bin ls. Move. Whatever. Okay. So we have these. Oh, of course.
Oh yeah, I think you just call them directory and file, but whatever, that's cool.
Oh, okay. Well, that's fine. I just want to demonstrate this. But, okay. So let's say we want to find the smallest thing. Okay. The smallest file. Well, I think we can just do a fold L over this, where fold L comes from the fold library. And I can't remember the exact type, and for some reason it's not giving me. Maybe I can restart psc-id in here. Will this work? No, it's not working. Maybe it's because I have two of these windows open. I can kill this one. Remain. Is this working now? Some type inference. Oh, yeah, psc-id would give me the type, wouldn't it? But yeah, well, whatever. We'll just use that then. A little bit strange. Okay, so it takes a foldable and a fold, which is so this isn't the same fold L that comes from the library, right? This is from this library, and we have this data structure now that's capturing the fold, and we want to sort of build up this thing. But the idea is that just like we can compose, you know, values of various types, we want to even compose folds together now. Okay, we take a fold and we take the structure we want to fold, and we get a value. So I want to fold over files, and I want to get back the size of the smallest file. Okay. All right. So it tells me that the whole has type fold from the element type, which is and you know, this object with a path and a size, and it's going to give me an int back. Okay. Oh, cool. This is working kind of nicely. So the library gives you all these different types of folds. Okay. And one of them is length, so you could just do something like count up all of the different count up all of the different things you see in the list. So in here, in this case, you'd fold and get 3. Okay. But I want a fold that's going to pick the smallest one of these elements. Okay, so I know that fold has various abstractions, right? It's like it's an applicative. It's also a profunctor. So one thing I want to do is map something over this that just picks out the size. Okay, so I know I'll probably want to do something like this. So lmap is something from the profunctor library. It just allows me to map on the left. So it's going to take one of these things and map it down to an integer. Okay. So if I save that, well, I need to import this first of all. Wish this was working. Import data.profunctor. Okay, now it's telling me that the size of the new hole is a fold from integers to integers, and it gives me all these different options. Okay, so I can fold with minimum, for example, so that'd be a good one. So let's try that. That should give me the smallest file. Right? Actually, this is a really nice demo of the whole stuff, Christoph.
Oh yeah.
Okay, so it tells me I can reduce my inputs, but I don't want to do that just yet because I want to write the largest file as well. So I can do largest file by just copying this and using maximum here. Okay, so now I'll actually reduce my inputs. Okay, I know that this only uses lmap, so I'll simplify that too. Okay, but the exercise said that we should be able to get both, right? So the final sort of step is to bundle them both up, and I want so I want to come up with a fold that will give me the largest and the smallest, right? So the sort of really simple way to do this would be to say something like, well, let's just use the same names, right? So I could just using record puns, I could just satisfy this like this, okay? Let's move these into a where. Okay, so if I wanted to find the smallest and largest files, this is the simplest way to do it, right? But I can do something a little more slick, because this isn't ideal, because if I have a lot of files in this array, I have to do 2 folds over the structure, right? So I have to traverse the array twice. But I should be able to do this in just one traversal, right? So I can do that by using the applicative instance for for the fold type. Okay. So let's just go away. Let's just simplify these a little bit and change the names to call this smallest and largest. And these are actually going to be folds now. Okay. Let's just put a hole in there. Okay. So it's complaining about no type class instances, but that should go away. So if I want to fold over both, all I have to do now is use the applicative instance. Okay. So I can say I want to combine smallest and largest. And I need a function that's going to take an integer and another integer and give me a pair of integers. Well, why don't I just combine them into the record that I need? Okay, I need to import prelude. All right, so because we don't have type annotations and there's nothing sort of forcing the type of this, it's getting confused about what this type is. Actually, maybe no, that's fine. Okay, so now the point is I can do this in a single. I can do this in a single traversal of the list, right? A single fold L, where I just use the both traversal. Now, so I can just simplify this. So this is sort of like fold fusion built into the library by using the applicative instance, right? So this is sort of a nice slick way of doing the exercise, but you have to use this library and sort of know a few of these abstractions. So that's what I was saying earlier when I was saying, you know, you can simplify a lot of this stuff once you have the abstractions at hand. Yeah, so that's it.
Just one little question. What's the bracket star?
Bracket star, this thing?
Yeah.
Yeah, so so this is, I think this is covered in like chapter 6 or something in type classes chapter. Oh no, chapter 7, sorry. But basically you can think of this as like, if you have some argument in a context and you have another argument in a context, and you have some function you want to apply in that context as well, then you can do this by, because of the way the types work out, you use this operator for the first argument, and then you can use this for any remaining arguments like this, right? So in this case, you could actually do this with a function called lift2, which means lift a function with 2 arguments. It's just equivalent to this, essentially. That's complain. I think it's in control apply. Yeah. Okay. So it's just basically shorthand for this function, which says, you know, if you have something which is of the right type, so it's an applicative, which fold is, and you have a function of 2 arguments, and you have 2 things of the right types to sort of slot into the arguments, then I can lift it up to get a fold of the result type. Okay, so it's like saying do both of the folds in parallel, and give me the result of the function applied to, you know, both of the arguments that you get from the fold at the end.
Okay.
So yeah, that's all I wanted to show. But actually, I probably should check this works. Let's try it out. Do this in psci. I guess I'm going to have to use pulp. Well, maybe I don't have to. Let's see. I use psc-package with the sources. I'm going to have to sort of do a little bit of trickery here. It's going to be a bit unpleasant.
Can't you put in a main function again, like yesterday, and then just use pulp run because it only uses the extrinsic?
Oh, yeah, we could do that. Okay. Do I have console? No. Okay, so I have to install console. We'll do that. psc-package install console. Okay. psc-package build. Okay, so I need control monad console log. We'll just say main is do that. actually. Right, yeah, good point. Okay, I don't think it's gonna, oh what a pain, but I can still do it like this, right? Node path is output, run node, the expression require, main. Okay, cool. Yeah, that was good.
Oh, yeah.
And then you could do things like, let's say you want to, lift, get another thing which is like the count of files or something. Then you could lift that over, add this as well. Lift that over length as well. Now we need to import length from fold. And then we can count the number of files as well, and it'll do this again in just one pass, right? Let's build that. Yeah, so it's just doing this all in one pass, but there's a whole bunch of stuff you can do with this library. It's pretty neat. Like I say, it's from Gabriel's fold L library, which is really neat.
Oh, cool. How would you rewrite the lift free?
All this stuff.
Like how you had it before.
Oh yeah, sure. So I have probably. So you'd have the. Sorry, go ahead, Crystal.
I think I understand why it didn't start the server, because you don't have a bower.json. Use that to
really?
Top level folder. Yeah, just started a server. You have a server inside the folds project now. Because that has bower.json.
Oh, interesting. Okay. Anyway, so you do it like this, right? You provide the function, and then you map the function over the first argument, and then you apply the function to the remaining arguments using this operator. So for the first one, you have this special case where you use $, and then you have to use this operator for the remainder. You could actually use this operator as well here, but you have to sort of lift up the function by using pure. Okay. But we typically get rid of this and we just use $, for the first argument instead.
Cool. Thank you.
Oops. Cool. All right, I'm gonna stop sharing my screen.
Well, I had a nice Twitter conversation about the typed holds. Basically, I did a little bait and asked people to give me the function for a certain signature.
I think that fold example is really slick. Actually, I might try that out a little more.
Yeah, that was pretty good.
Yeah, I mean, it's pretty simple, right? I mean, it's just there's nothing sort of tricky going on there, but I guess it's using some of the type classes stuff, but. Yeah, it's simple, but it's pretty cool.
Yeah, I got a pretty cool idea doing a Twitter conversation, or that I'm going to put in the motivation section. It's usually you say that or I've read a lot that people have problems learning abstractions because you can't learn the abstraction before you saw the concrete case. Right? You can't give someone the medicine before they felt the pain, basically. And typed holds can reverse that because you're going from the concrete case and it finds the abstract one for you. Right? So the example I did was, I think the alt alternative type class. And it's kind of, well, you kind of need to know about that class before you can apply it. But there's lots of use cases for it, and I think it gets resolved or rewritten all the time because people don't know about that function or that type class.
Anyway, I'm gonna take off now and crack on with some libraries, I think.
Cool. Thank you.
Thanks for going through the exercise. That was interesting to see as well.
Yeah, not a problem. Thanks for helping.
Sure. All right. Well, enjoy the rest of your weekend, everyone. I'll talk to you in a bit.
Cheers.
Bye.
Bye.
So I'm not sure what anyone else wants to do. I mean, I could go through another exercise, or if people want to call it a day, I don't mind.
I'd be happy to watch another exercise.
watch me fail.
No, watch you progress.
Progress, yeah. I'm going to progress. I'm going to get good at these holes. I'm determined to learn them. But right. So it's not in master yet, is it? The holes.
It is in master.
It is in master, isn't it? But so what you sent me or sent on the? Oh, I didn't think that was merged. Where have I? Hold on. I'm just going to quickly look. I saved it. Oh, so that's probably why I can. Oh, it is merged. Yeah, derp. Sorry, I thought it was waiting for pull request. I was like, what? How come I could use it? But it's not even in. But I'm on 0.9.
Yeah, you don't get the suggestions for things that you can put in. What you get is that all the types that are in scope. But what my plugin it shows you the things that you can put into the hole to solve it.
That's why I'd be going mental. I'd be like, this doesn't help me at all. It's just telling me what types I've got. Okay. That kind of makes up a lot. Okay, I get it now. That's terrible. Cool. Okay, well, I can share my screen and then we can sort of watch me fail a bit when I somehow learn it. Cool. Anyway, yeah, so we've done this one, which ended up in a pretty cool way, which I would have never done it that way. But anyway, so we want to pass it a string, and it's meant to return a just or a nothing.
Okay.
We haven't done this before.
Mm-hmm. This is new.
This is brand new. Okay. Definitely no hacking. Oh, bye, Claudia.
Oh, bye. Bye-bye. Okay, so I think the all files tick method is kind of a good hint about how we want to go about this. So I think we're going to do a fold here. But because that function that we're going to call is going to be recursive, we probably need to make a where binding and give a new name to that function.
So just a normal fold.
Probably fold L.
And then we're going to fold over a function. So
by fold, we are not recursing.
I don't want conflicts here, you know. Come on, guys.
Mom, Dad, stop arguing.
Can someone just help me? Wow.
So yeah, I'm not quite sure how to help you out here without just giving you the solution. That's kind of the thing right now.
Oh, right. Yeah. No, that would probably help at this stage because I'm so confused.
How can we do this? How can we break this down into steps? What if we write a very simple function? Let's just write a few utility functions and see if we can put them together.
Okay.
Okay. So let's just put in a typed hole there or something. We don't care about that fold L. The utility functions are going to be inside the where. Inside a where. Oh, done. So let's do a where then. Right, and you in the case 2, you say if the file matches the string. Okay. let's write a function called path matches that takes in the path. There's a capital A. You might want to do that small.
Oh yeah. Try. Oh, do I need to give it a?
If you want to give it a type tree, you start with path matches : :
Yeah. So it should be a.
It takes in a path, gives us a boolean. That's the idea. Basically, we're going to compare it to that string over there. Okay. If we want, like, because S is a string, we need to turn the path into a string in order to compare it with S.
Yeah.
Right. So, is there a function to do that? Maybe
A path to string.
Yeah.
Oh, there it is.
Okay.
Oh, is that going to find it there? Yeah, cool.
Okay.
So file name, and I need to pass it path, then I assume.
Mm-hmm.
Yeah. And then that should return me a string. And then I need to do, then I need to filter these guys, I guess.
Well,
Or do I?
if you have a string and you want to compare it with F, with S, with which also is a string, you can just write it equals S, right? And if we show the file name of a path and it matches our string, then that's true, and otherwise it's false. So we can just say it's equal to S.
Double equals single.
Double equals, exactly. Yeah.
Yeah.
Right, does that make sense?
Yeah. So we've done this bit. So we're gonna.
We're not starting this from top to bottom. I just said we start writing some utility functions and see if we can stick them together later.
Okay.
Right. And so now can we take a look at the file system data structure again in path? Right. What the type of that is. That's just a directory. Sorry, that's just a path. So a directory contains a list of paths. Right, so that's a pretty good question from Sippy here. How do we get all the files in the directory? How about we do that one next?
Just the files. I can just use only files.
Okay.
I guess. But that's going to return me all files. So it's a similar thing. So I've got to filter something, haven't I?
I'm not quite sure. That seems like it returns all the files in your file system.
Yeah, that one does. But it's going to have to be something similar. That's what I was getting to, I guess.
Okay.
So I guess I need to filter.
Yeah, so what he's saying is let's start with having the files or directories in a specific directory. Right, so we're going to assume that the top level directory contains the file that we're looking for. Right, so if we call ls on root, we're going to get all the directories below it, or all the paths that might be files right below root.
Yeah.
Right.
Just for now.
So let's write a function that says, yes. So what I'd like to do is I'd like to write a function that takes in a path and tells us whether inside, like it takes in a directory and whether inside that directory is the matching file.
Yeah.
Right? Like one level below it. Does that sound okay?
Yeah.
we could say, call it something like where is one, or where is one level or something.
Child?
Okay, let's do that. Where is child? That takes in a path. Okay. And checks whether, let's just return a Boolean for now, and checks whether there's a matching file inside that directory.
Yeah.
Okay. So the first argument we take is a path. You could just call it path or something.
Yeah.
Okay. Right. Okay, right. So, and then what we're going to do is we're going to say we're going to ls that path, right? Because we need to look at all the files inside that thing. Right. And then we need to, what that is going to return us, what type is that going to return? An array of path.
Yeah.
Right. And then what we could do is there's a function called any inside data.array.
Oh.
And again, the functions usually go to the left of the things. You could use the hash. If you use the hash thingy, you get like an apply that works forwards. But you just start with any with a.
Oh, any.
Any, exactly.
Oh,
That
we said Emmy, like the Emmy Awards.
Ah, sorry.
That's cool.
Yeah.
Traversable.
Foldable. Both are the same.
Okay.
And you say any, and then
Just become.
Sorry. So CP just asked if you could like write a little, like describe what where is child is supposed to do, and maybe write a little comment or something.
It's finding the children contain the file.
Okay. And does that mean that it's gonna look into, like, if we have a directory and inside that directory we have another directory, it's gonna look into inside that directory as well?
So it's got traverse.
I would like it to not do that for now. That's the idea. And then we're gonna see if we can make it do that. Right.
Okay.
So,
Yeah.
okay.
So what does the any do?
We could take a look at the type first. I might clear things up. Maybe save once, and then there you go.
So, Boolean algebra.
Yeah, just think of B as bool.
Yeah.
Right.
Okay.
And F is array here. So we could write the type out with like with bool and array put in there. Maybe that would help.
Oh, what? Write that type out.
Yeah, just write that type out with foldable and Boolean algebra replaced. Just in a comment or something so we can look at it. Okay. So maybe the type signature is a little easier to read now. Maybe we could like deduce what that does.
So, so it takes a function that takes A and returns a Boolean. So that's like a filter, basically.
Mm-hmm.
And it takes another argument, which is an array of A, and it returns a Boolean. Mm-hmm. Okay, so we've got to pass it a function, which is not a function. So here we can just pretend that's going to be a function, and then that's our array.
Mm-hmm.
Yeah. Oh. Oh, whatever. Okay. Oh, it's just a hole, isn't it? So that's okay.
I was just thinking maybe we could like think about what any does. What does that function do? All right. Basically.
Oh, well, to me, it just looks like a filter.
Yeah, that would return an array A though, right? It would just return those elements that contain that matched, like for which A to Boolean was true.
Oh, true. Okay.
It returns a Boolean in the end. And so the name of the function is kind of helpful in that regard. It checks whether any element inside the array returns true for the function. That's what that does. Does that make sense? Sippy says there's also a function called all, which has the same signature. Does that help? Okay.
Yeah. Okay, cool. So that's our way of matching, excuse me, of getting our path to match our string, I guess.
Mm-hmm.
Okay. So here we need a function then to do that.
Can you check what the type of that thing is again?
This one?
Maybe in PSCI.
Ah.
If you just refresh over there, does that work?
String. Oh no.
I think the arrow above, because this is for the whole okay. This is the one for A. Oh, interesting.
Path.
Path to Boolean. Right.
Which is what that is anyway. Okay.
You already have a function of that signature.
That guy.
Yeah.
Oh man.
You could just put that in there. Right, so if you read that out, does that make sense?
Yeah, totally.
Right? If any path matches for an LS of P.
Yeah. Damn it.
No, it's all good.
Yeah, cool.
Just found it interesting when you said where is child has the right type. The function where is child, if we pass that in there. Right, so if you put back in the hole after the any.
Instead of that.
Yeah, if you make that a hole again. Right, so what you said was that where is child actually has the right type.
Yeah. Right,
so we could do that, put that in there recursively. And I just wanted to think about what that would do. Does that make sense? If you put in where is child there, that's also going to be a valid function. Right. So what's that's going to do is it's going to if we think about it again, what any does. So ls gives us a list of, or an array of paths, right? Yeah. And then any is going to apply where is child to each of that paths.
So that's how we're getting to the children then.
That's gonna traverse all the way down. I mean, writing that function is going to be kind of tricky, but at least we could just call it a day and say we have a simpler function. We can just check whether or not there is a file inside that. Like inside our tree, there's a file that matches this.
Yeah.
And that must be where is child.
Yeah.
We could try that, and then we could try that out in PSCI at least, if that works the way we intended it.
Yeah, that's cool. So what do I want to pass up here?
If you say where is child, and it expects where is child expects path as its first argument, and we need to start path.
So root.
Yeah, let's just put a root. Okay. And then we could go into PSCI and try that function out and see if it works.
Okay. Cannot match type.
Yeah, you need to say that where is returns a bool, right? Because we're not actually, the top level function, where is does not return a maybe path yet. It's just a Boolean, sorry.
Yeah, that's cool.
No, try that one out.
Take from this code. Okay. Oh, I've got past that string. Hello. Of. I should get one that's a bit deep. What sort of string does it expect? Oh. That's not going to work there, is it? That's just a file.
Try that. False.
False.
Right. So if you'll, it's going to need the entire file path, not just the file name. Right. Takes the entire path. False. Interesting. I would have expected that to work. Huh. Oh, I understand why that didn't work. So the problem with where is child is that we like the function, like we passed where is child to any, right? But where is child only looks inside the children directory of a directory. It like looks at the children of a directory. If we pass a file to where is child, it's going to call ls on that and return an empty array. And then it's going to say false because, well, if there's nothing, then if there's no elements, then any does return false.
Yeah.
It doesn't match anyone, right? Anything, right? So what we need to do is in the function that we pass, like where we pass to where is child to any, down there. Yeah, exactly. There. We need to pull that out into a different function, actually. Okay, so the idea is that we'll try path matches first. Oh yeah, we could try path matches inside the REPL. Oh yeah, put path matches in there, sorry. Yeah, and then try out if that works. Good.
Oh, shit. Oh.
Okay, so it's going to return false because it only walks down one directory, like we said. Right. Where is child only walks in one directory. So maybe there's a file in root. Can we look at that? But it seems like there's only directories inside root. So maybe you could add a file just so that we can check.
Oh, right, yeah. Is that what you're saying?
Yeah, but no, don't make an array, just a file. Okay, and now you need to put a comma in front of directory. Oh wait, you have a comma already.
Yeah.
It's kind of weird though.
So I don't want that. Oh no.
But slash poop. Right. And then you want to put the comma in front of the directory instead of, just to keep it consistent. Yeah. Okay, so let's try that out.
Hey.
Hell yeah.
Okay. Right.
So, path matches works. Right.
But, yeah, but it's not traversing down, is it? Because when we start looking for something else, then it goes, oh, I don't have a clue. Yeah.
Only looks in the first, like one level deep. Okay.
So we need a new function.
Yeah. One that traverses down. It's not called traverse down. Okay, whatever. Let's call it traverse down. That's not true. I'm going to find a better name eventually. The type is still path to Boolean.
Okay. Come on.
And what traverse down is going to do is it's going to
It's going to have to take something.
yeah, we need, is there a function that checks whether something is a file or directory?
Is directory.
Yeah, that works for us. Okay.
So is a directory. But we want to do more than just that.
Let's do if this directory A, then, and then we're going to, if this directory A,
Do you put it on a new line?
yeah, maybe you could put the if down on a new line as well.
Okay.
And
All on the same line. What's the, because it doesn't have the,
I've started to like this how we put it. That's just fine. Just use that one.
yeah.
Okay. So if if A is a directory, right, so if that's a directory, then we're gonna do where is child inside for that directory. So we're gonna go one level deeper. Right. And else, and that's gonna mean that we're looking at a file. And we can just use path images. Okay.
Ah, okay, I get it now. Oh dear. Cool.
So let's try that one.
It's not like it. It's not.
There's some data foldable has unused imports. Doesn't show them. Whatever. Let's just try it out. Let's just try out the function. These warnings don't matter.
Okay. Hey. That is good. Okay. Well, I mean, yeah, that's really smart. Oh, okay. It's just totally different way of thinking, isn't it?
It's recursion. It's kind of
Yeah. Well, I mean, I did quite a bit in JavaScript, but I don't know. I don't think I ever thought of it because it is just facing problems slightly differently, isn't it? That's cool though. That's really handy. Okay. So that's just going to return true. Cool. I'm probably going to have to call it at night, to be honest.
that's fun.
That's super, super helpful. That's been much appreciated.